Hi, this is Eric White. This is the next screencast in this series of screencasts on recursive pure functional transformations. In the last screencast, I introduced these types of transformations, and I showed a super simple example where we changed the name of an element in the middle of a recursive pure functional transformation. And in this screencast, I'm going to show what the pattern is for replacing an element with a different element in the transformation. A really good scenario to show this functionality is a very simple transform of OpenXML word processing ML to HTML. Here I have the main document part of an OpenXML document. This is standard word processing ML. I'm putting it in this form so it's as easy to talk about as possible. In a real-world example, you would be using the OpenXML SDK and you'd be opening a document, and then you would be getting the main document body part, and then you would be retrieving the XML from the main document body part. But that's not necessary for our discussion today, so to make it as easy as possible, I've simply grabbed the word processing ML from that main document body part and put it here into a little string. So let's write a recursive pure functional transform to transform this word processing ML to HTML. First, I'll parse that string into an XML tree. And now I'll call the transform, which we haven't written yet. If you'll recall, because of the way we're going to declare transform to HTML, we're going to declare that it returns an object. I have to cast it to an X element when I call it. So I'll right-click on transform to HTML, and I'll let Visual Studio generate a method stub for me. But I'm going to change it just a bit. I am going to change this to an object, and instead of taking an X element document, I'm going to have it take an X node node. And I'm going to put in the identity transform here. So there we have our identity transform. Just for the fun of it, we'll call console.writeLine, and we'll run it, and we get the exact same word processing ML document out of there. Now the first thing that we can do is let's transform this W document element to the HTML element. One thing that's going to help me here, will make my life easier, is that I am going to add a couple of modules from the OpenXML Power Tools. This will give me the pre-atomized X names for all of these elements and attributes. I've copied the two modules that I want into this directory, so I can add existing item, and I want pt openxml util.cs, and I want pt util.cs. I'll have to add a using there. And now let's write a transform to transform that document element into an HTML element. So I'll say here if element.name is equal to w.document. I'll tell it I want to return new X element HTML. For these HTML elements, I'm just going to put strings in for the various X names. In other examples where I'm doing a much more robust and comprehensive transform to HTML, I've pre-atomized all of the HTML names. Now I don't need to grab any of those attributes from the document element. And in fact, because this is a document-centric transform where we are transforming from one dialect to another, in other words, we're transforming from word processing ML to HTML, we're going to do a few things differently here. The nature of the transform is still the same. We're going to be approaching it in a certain way because it is a transform from one dialect to another. So I'm going to return new X element, and then I am going to take element dot nodes dot select Now I did something a little bit wrong last time, which is I really don't want to have the identity transform follow here. Instead, if it's not one of the elements that I'm going to be transforming, I'm just going to return null. Now this null is going to be returned to the recursive transform that called it, and that's going to be placed as content into its parent X element. And if you'll recall, null is a valid value. It just simply means don't put anything into that X element. And I'm also going to come down here, and instead of returning node, I'm also going to have it return null. So now, when I run this transform, oops, I forgot. I'm going to have to add references to the OpenXML SDK. So I have both of those in my recently used references list. I'll add those. Now let's run it. And we see we transformed that document to a single element that has HTML in it. Let's enhance this a little bit more. Let's now say that when we see the body element in this word processing ML, we're going to generate the HTML body element. And to keep things simple, I don't need to surround that return in curly braces. We want to keep our transform to be as short as possible. So now if I run it, we now have the HTML element with a child body element. The next thing let's do is let's look for the WP element, and let's replace that with an HTML-P element. And we want this exact line right there, so I'll just copy and paste it. And if we run it, we now see that we have empty paragraph elements for every paragraph in our document. Now, one thing that we have here is we have these runs below the paragraph, and those runs could potentially have different formatting on them. We don't see it in this particular example, but it certainly could happen, and if we're writing a more robust transform, we want to transform those runs to HTML span elements. So let's go do that. And now if we run it, we now see our child span elements within each paragraph. Now these run elements can have more than one T element in them. So let's do the next step in this process. When we see that run element, we will retrieve all the child T elements and concatenate the text together and put that text in the span. We already have our code to look for the run and then generate a span. So what we really want, we want this to result in text that is being returned by this expression right here. The expression that we have right here should be a text string. So to get that text string, we're going to type in element, and we're going to type in elements. We're going to grab all of the WT child elements. And then the next thing, now that we've got these WT child elements, we have a collection of elements and we really want a collection of strings. So what we do is we do a projection. And in linked XML, as you know, as you've seen, if you cast an X element to a string, it retrieves the textual content of that element, and the value of this expression is that textual content. Now this returns a collection of strings. It's perfectly valid to send a collection of strings as content into an X element. So let's leave it as this. Let's run this example. And sure enough, we can now see that we have the HTML element, we have the body element, we have all of the paragraph elements, we have span elements, and then the contents of each one of those span elements is the text of those paragraphs. Now, it would be pretty nice to also transform text that is styled with heading 1 to an H1 tag and text that is styled with heading 2 to an H2 tag. So let's do that. If we look up here, when we have a paragraph, this paragraph P, we can see that if we get the PPR element and then we get the PStyle element and then we get the val attribute out of that, and if that value is heading 1, then that means this whole paragraph right here is the paragraph that should become an H1. So we're going to put this transform in, and we're going to put it in right above the transform for the paragraph. I'm going to write it like this. I'm going to say if element.name is equal to w.p, and if element.elements w.ppr dot elements w.p style dot attributes w.val dot first or default. So this gets us that one attribute if it exists. If it doesn't exist, then the results of this expression will be null. I talked about this when we talked about extension methods in the screencast on extension methods, that this is an interesting idiom that you can write in this way so it can't fail. You have this element, you know it's an element, you can get the collection of elements of that element. That's always going to return a collection. That collection might be an empty collection, or the collection might have one in it. We then dot into the extension method, and that extension method is going to get all of the child elements for every element in its source collection. And in this particular case, there's either going to be one element in its source collection or 0 elements in the source collection. So this is either going to return a collection of one p-style element or a collection of 0 p-style elements. And again, this .attributes extension method, this is going to look for the WVAL attribute for any element in its source collection. And that source collection is either going to be an empty collection or it might be a collection of one p-style element. So this attributes extension method is going to return a collection with either 0 attributes in it or 1 attribute in it. And when you dot into the first or default method, this won't fail. If you have a collection of 1 attribute, it's going to return that single attribute. If you have a collection of 0 attributes, that's where the default comes in, and the default value for any reference type is null. So this is either going to return null or it's going to return a single attribute. If we look up here, this first paragraph up here, it's going to return the wval attribute. The second paragraph, there is no PPR element, so that expression is going to return null. The third paragraph, the expression is going to return the single wval attribute, and so on. Now that we have this expression that is either going to return a single attribute or return null, we can just cast it to a string. Null casted to a string is just null. That attribute casted to a string is the value of the attribute. So now I can test if it's equal to heading 1. That's the value up here. And if that's true, what I want to do is I want to do the very same thing that I did right here, except that I want the resulting element to be an H1. And I want to do the exact same thing for H2. So I'll test this against heading 2, and if it is true, I'll generate an H2 element. And if neither one of those are true, then it follows through and generates a paragraph element. So this is a really good example to show replacing of elements. We've replaced a lot of elements in this transform. And when I run it, sure enough, we can see that it replaced the first paragraph with H1. The second paragraph remained a P element. The third paragraph became an H2, and so on. And just to show that this really worked, I'll select all of that text. I'll start Notepad. I'll do File, Save As. And if I double-click on that test.html, we can see our HTML page there. Here is the source word processing ML document that contained the markup that we used for this transform, and side by side is the HTML that we generated for it. So you can see the pattern that we use here. In each situation, we look for a particular element, and we might look for that element in a fairly elaborate way. We might be looking at the name of the element. In these cases of the headings, we're looking at an attribute of a descendant for testing whether we have found the paragraph element of interest. These tests can get very involved in certain cases. You can be looking at previous elements or next elements in the collection, or there's a lot of different ways that we will want to select elements in a transform. But I think this gives you a pretty good idea of what you have to do to replace a single element with another element in a transform. Here is the exact same example program written in JavaScript. Up here at the top, I initialize the string to the XML. This is how you have to do it in JavaScript, of course. And here is the transform to HTML method. There are a few minor differences. I didn't have pre-atomized X names and X namespaces, so I needed to change the code to actually new up a new X namespace for this W element. Down here where we are testing against X names, I test using the plus idiom where I add the namespace to the local name. That works just fine in JavaScript as it does in C#. Right here, this is the equivalent idiom for testing against the type of an object. Instead of testing against the type, what you do is you look at the node type property, and if the node type property is equal to this string element, then you know you have an element. And down here are all the various parts of that recursive functional transform. It looks a little bit different, syntax is a little bit different, but it fundamentally operates in exactly the same way. You'll notice right here and right here, I had to use the idiom of newing up an x-enumerable object in order to get to the extension methods. But once I'm in the extension methods, they also return an x-enumerable, so you can then dot into the attributes extension method just as easily. And then you can call first or default because the x-enumerable class uses as its prototype the enumerable class. And this transform to HTML, after it does its work, all this example has to do, because it's JavaScript running in a browser, is write that HTML to the document. And because that's right here in this script element that's in the body element, we can just press F5 to run the example. And we see the results of running the example, which is exactly the same as what we saw in the C# example. So there you have it. That's all there is to replace an element. In the next screencast, I'm going to take a different scenario. I'm going to take the scenario of removing the proofing elements from a word processing ML document. And so what we want to do is show how to do a transform where we are deleting elements, or in other words, not cloning certain elements from the source XML tree into the destination XML tree. That's all I'm going to cover here. Thanks for watching. Come back often to openxmldeveloper.org, and feel free to come to my blog at ericwhite.com and follow me on Twitter at ericwhitedev. See you in the next screencast.